Hello everyone, myself Sachin Methani, and today I will discuss the preliminary thesis presentation on the design of an antenna using PET transparent substrate for ISM application. Now, these are the table of content: introduction, literature survey, inference drawn, problem definition, proposed work objective, design methodology, time plan, and then references. In an introduction part, generally PET is defined as a polyethylene terephthalate, and it is flexible, transparent, lightweight, and low cost, and strong. For those property, it is used for the packaging of the essential food. PET have a dielectric constant of 3.2 and the loss tangent is 0.02. And there are several nanomaterials available: I2 indium tin oxide and ZNO, silver and iron oxide. There are nanomaterials are prepared by the Solgel process, and the thickness measurement of the nanomaterial by the AFM, atomic force microscopic. The sheath resistance measured by the 4-probe method. In the Solgel process, generally there are several materials are available like silver, aluminum, nickel, iron, silver oxide, and ZNO and ITO graphene. And some of the material are transparent nature like indium tin oxide and ZNO. There are several techniques to prepare the conductive materials at a high nanomaterials like high energy ball milling methods, melt mixing, Solgel process, thermal evaporation techniques, ion implantation, sputting deposition, chemical vapor deposition. Generally, Solgel process is a wet chemical process of the nanomaterial preparation, and it has two types of approaches. One is top to bottom and another one is bottom to top approach. Generally, in the top to bottom approach, we have a bulk material, well conducting material, and it will convert it into the powder form. After powder form, it will convert it into the nanoparticle. This is the one approach which is top to down methods. Generally, in this method, the mechanical grading and erosions are. And in the bottom to up method, there are atoms are converted into cluster, and the cluster after cluster it will go to the nanoparticle. After cluster it will convert into the nanoparticle, and this is the bottom up method. In this bottom up method, generally aerosol techniques, chemical precipitation, and the self assemblies are included. Now the another methods for the sheath resistance measurement is the 4-probe method. In the generally 4-probe method is used to measurement the sheath resistance of the nanomaterials. In this technique, generally in the figure, this is sample which is in conducting nanomaterials. In 1 and 2, we can apply a current along the sheet, and when we apply a current, 2 and 3 terminal gives the high impedance output voltage, and after the high input voltage and current, we can substitute in the formula when we can get the see the resistance of the this nano materials. Now the application of the PET based antenna is variable application, industry application, medical application, and scientific application, mobile application, and the IoT applications. This is my literature review related to my thesis, and in this generally this first research paper in the proposed antenna is dipole antenna fabricated using PET transparent sheet of 125 micrometer thickness, and the conductivity of the patch antenna is made of silver ink, whose thickness is 5 micrometer, and the PET material have a dielectric constant and loss tangent. Dielectric constant is 3.2 and loss tangent is 0.02. The antenna is operated at 2.45 gigahertz frequency. The bandwidth of this antenna is 45 megahertz, and the return loss is minus 28 dB. And the gain of this antenna is 2.2 dBi. Application of this proposed antenna is set-top box application and remote controller devices. Now this is the literature review second, and in this literature review, generally and the proposed antenna is made of PET substrate which is transparent and flexible in nature. And the patch material is also a transparent in nature like ITU. And in this paper generally we are dealing with the copper and ITU's transparency, and this optical transparency is measured by the SAM and NI spectrometer. After after this methodology, we can deal with application. In the application, this is a variable and IoT application. This proposed antenna is used for variable and IoT application. Now this is the literature review number third. In this paper, generally the proposed antenna have a low cost substrate which is PAT, and generally this silver ink nanoparticle is used for deposition. We can use the inject building. And the inject building we use design the patch using silver nanoparticle. Patch sheet is flexible and transparent in nature, and the shape of the patch is in Z shape, and the silver ink is used as an antenna, using this antenna because the sheath resistance is 0.3 ohm per square, and the conductivity of the silver ink particle is 1.1 to 10 to the power 7 Siemens per meter. And we are applying the coaxial feeding techniques, and the gain of this antenna is 1.44 dBi, and the operating frequency is 2.45 gigahertz. And the application of this proposed antenna is variable and ISM application. This is our literature review number 4. In this paper, generally the proposed antenna is designed using PET substrate, and that is flexible and transparent, used for millimeter wave for high bandwidth. And the the patch has the shape of T, which is symmetrical in nature, and the radiation of the antenna is omnidirectional, and the impedance of the transfer frequency is around uh, uh, 27 to 30 or 40 gigahertz, and their maximum gain is achieved at 34 gigahertz. The antenna have the applications such as variable and 5G application. Now there are the inferences drawn from the literature review. The FR4 and ABS are not flexible and transparent substrates, such as PET is flexible and transparent material for which it is widely used for the latest antenna designing. Most of the PET-based antenna application are ISM application, transparent antenna application, and the variable application because its flexibility. The ring resonator test has a less coupling gap, coupling loss as compared to the T-resonator test. The ring resonator test is widely used to finding the material property like dielectric constant and loss tangent. The copper is a commonly used patch as a conducting material, but there are several nanomaterials are available which have better performance as compared to the copper patch. The soldier process is used for the preparation of the nanomaterial, and the conductivity in nanomaterials depends upon the resistance of the nanomaterials. And the sheath resistance measurement is which is commonly used for the four probe method. The AFM, the atomic force microscopic, is used for the thickness measurement of the nanomaterials. For the operating of the wide band frequency, the size of the antenna should be small. There are some problem definitions are there. The microscope patch antenna has a low resonant frequency, low gain, and low efficiency. In the last few years, their most widely used substrate is FR4. ABS is less flexible, but not in transparent substrate. ABS substrate is widely used for the antenna designing. And ABS is used for 3D printing technology. It is less flexible and not transparent substrate. After the ABS, one of the substrate which is flexible and transparent is nature was PET substrate, PET substrate. For the better conductivity and optical transparency, the researchers are dealing with the nanomaterials. Copper is one of the transparent materials, and its conductivity is less than the nanomaterials such as ITU, ZNO, silver ingot. And the silver has a better conductivity compared to the copper, but it is not transparent as ITO material. For the transparent purpose, there are several materials like ITO and ZNO which have a better transparency. And there are several methods for preparation of this nanomaterial are solvent process, thermal evaporation process, chemical evaporation, and the soldier is one of the widely used method for preparation of the nano material. This is our work project objective, proposed work objective, and the objective of this is work to design and simulate a transparent flexible PET substrate or patch antenna. Determining the dielectric and loss tangent of the paired substrate using ring resonator test, and determining the sheath resistance and conductivity of the proposed antenna using full prep technique. Now these are my design methodology. First, we can determine the dielectric constant and loss tangent of the PET substrate. After that, we can design the our software part in NCS HFSS software. After that, we can prepare the nanomaterial for the solder process. After that, the sheath resistance measured by the four methods and the thickness measured by the AFM methods. And the measurement of antenna result and measured and simulation result compared. Now this is my time plan. These are my references. Thank you. If any query, you can put the message on my comment box. Thank you so much. Have a nice day.